Okay, thank you guys. There was a little bit of technical issue here. And as you know now that we are officially sponsored by IDA, so that's why you guys had the good food, good dinner. So big applause to IDA. So today I'll be talking about how many of you have attended my talk in Git Camp? Okay. So Mogund did a repeat talk today. I'm going to do a continuation talk. So whatever I spoke in Git Camp, I'm not going to cover any of those here. I'm going to talk about what's going to happen next. So in Git Camp, I kind of use some tools. Tools to steal data from some of the popular apps like WhatsApp, Instagram, Angry Birds. The kind of data that you can extract from these apps are like, on a very basic level, you can get the resource files like images, audios, videos, or whatever. But for applications like WhatsApp or Evernote, those kind of applications, they store the real data in the application in different directories, and there are tools to extract those file locations, and those files are really unsecure files, like lying in plain text in those document directories. So imagine somebody has got access to your mobile device. You can just use one of these tools to steal data from your applications. Now you might store something, you might not store something really sensitive in your application, but you might also store something. I know a lot of people who use heavily Evernote, who use Notes application, who use even WhatsApp heavily to communicate. So it depends on what kind of data they are storing there. So today I'll be talking about few things. I thought to cover everything, but it looks like I cannot cover everything. So probably there are going to be another session on the runtime exploration part, how to stop your application from injecting code in runtime. But the thing that I'm going to talk is how to protect data on network, how to protect data on the device, and even how to protect data even if the device is jailbroken or whatever. The first thing is protecting data on network. This is a screenshot from the demo that I showed in Git Camp. So this is capturing Instagram traffic. So they store their images in AWS, and when they pull information, you can sniff the network. They make HTTP request to pull this information. It's not even HTTPS, and you can get the request, the response, and you can play with the formats of parameters. The application that I'm going to showcase today is a very, very simple application. I heard about this application somewhere that there is this application called Fireport or something. So the application is this. So basically you store all your information, all your credit card information or your bank detail information in one place. And if you die, for example, if you die like in accident or somewhere, then all this information will be emailed or sent to your wife or spouse or whatever. Now this is a very useful application. Although they use HTTPS on the website. Imagine you are building a mobile app for that. How is it going to work? So for the demo, I have got a Rails application running. It's a very simple Rails code. I'm going to just start the demo. It's a very simple application. You enter your email ID, you enter your password. uploading the URL here, the IP change obviously. I want to obviously because the server is not running. Now this will work. Okay, so that is my credit card number, expiry date, and just feel free to use it. But the couple of things that I did to make this application work. The first thing is that I made a HTTP post request with my email ID and password. I got a JSON response, and I stored the JSON response on my document directory, and I'm using that information. Now we'll talk one by one. This is obviously the normal way I made this connection, like Google said, you need to pass this accept and content type, HTTP, whatever. Okay, so let me run this same application on my iPad and try to sniff the network and see whether I can extract the username and password or not. So there is this network sniffer that I'm going to use called Paris. You can set up your Mac as a proxy. So this is your setup. And whatever information I'm going to, or whatever request that I'm going to do here, that should appear here. For example, I search for google.com, that appeared over here. So you can capture the network traffic. But now what I'm going to do over here is I'm going to run this application. If you see over here, there's this request that I'm making, and there's this post request that I'm making with these are the parameters. This is the email and this is the password. Now this is I'm sending as a clear text. A lot of time the way people build web server is they accept the password as clear text and they convert it to a hash. MD5 hash. Even though they store the password in a hash in the database, they accept the password, and if it's coming from the proper user, they apply a salt and then verify whether the password is matching or not. But even in this case, I'm just passing in a plain text. If the client or the application has a web version, I can go to that particular site, use this email name and password to log in, and I can do whatever I want to. I can steal data, I can delete records or whatever. So the basic level of encryption or the security that you can do is you can create a hash on the client side itself. It's like creating a MD5 or SHA-1 or SHA-256 hash. The way this digest works is one way. So it's basically it's based on how many characters or how many bits your password is. Then it appends some zeros and ones, and then it performs some AND or OR logic and all those things, and then some electronics stuff. I don't know. So it's like
lots of math.
Yeah. So it's like a lot of algorithm that do. I can probably show you a demo how this works. It's like some random password. It's convert. This is your binary, and then your message contains 72 bits or whatever, and then they convert it into a hash. So let's do that. Let's put that in our application. I have got this two classes called encrypt_pass.hash and .hem. I'm just converting into a SHA-1 hash, and let's just do that. So my server doesn't handle the digest setup now, so I'm just going to create the digest for this password. And assuming you can capture that thing through a sniffer, let's say. So this is my hash. So instead of plain text, now this is what I'm going to pass, let's say, to authenticate. There's an interesting discussion that we had recently about rainbow table, how we can look up this here.
Sorry, is it okay if I interrupt you?
Yes.
I don't see how this will work, because this is okay if you already have the hash in the server stored in the database. But how are you going to get the hash on the server in the first place for the registration part of the process? The problem we'll have here is that your hash will end up being the password. So if I sniff the hash, I'll pass that to the server.
Yeah, so that's what I'm getting into. So it's like,
Okay.
So basically, although
man in the middle attack, right?
That's what he's doing right now.
So it's like I'm demonstrating one by one. So even though you create a hash and you're passing it along with your request, so now whatever user sees is not plain text. So let's say that the user doesn't have any idea about the server or whatever, and then what you enter here is your clear text, right? It's a simple rainbow table lookup. The more complex your rainbow table is, the more information you can find out. But coming back to your question, how you create this hash, right? If I'm just passing it as a password to my server side and there's no logic behind it, then I can just use this as a password to log in on the server, right? But then the thing that you need to do is, rather than just creating a digest randomly, you need to create it always with a sort, right? And how you get this sort from server and how you store it in an application, that's the tricky part. So let's say you created a random number along with this password. You append that number, or you just repeat the password twice or whatever. Then you create then you get a hash that's most likely going to be difficult to crack. For example, if I'm going to, let's say this is the password, right?
You're off the screen.
So I just added this random sort, whatever, it's a random number, right? Now this is my hash that was being created along with the password plus this sort, right? Now if I'm going to use the same thing, it's probably not going to find out the result. It's probably cannot crack this because it's hash with a sort. So coming back to how you should secure or encrypt your password is at least use a sort if you're using digest, or use some encryption algorithm. Then again, your security completely depends on what is the sort or what is your encryption key, right? And where exactly you're going to store it. The ideal place for storing these things are keychain. I'll come to keychain later. So anything related to sensitive information, you should store it in keychain. Other than that, there is something called NS URL challenge. So that kind of works with your certificate. So rather than passing your username and password directly, you call a particular URL on the server, and the server challenges the client to pass the credential. There's basically you do the authentication in 2 steps, and obviously you can stop users from sniffing the network just by upgrading to HTTPS. So that's about network security. I won't be touching a lot on authentication challenge because I don't have a server which can challenge the client. So, but it's very straightforward. There is one line of parameter that you need to pass.
www.authentication.
Coming back to how to protect the data, let's just see what happened for this example that I did, right? So I stored this JSON file directly in my document directory. And if you open this contains the response. Now, accessing this document directory and library directory is fairly easy if you use something like iExplorer, or even if you just jailbreak your phone, you can access to this document directory and library directory. So this is where WhatsApp stores all your messages. This is where Evernote stores all the unsynced notes, and they don't encrypt any of these things. It's completely plain text. Yeah, I've had it.
I believe there's a difference between premium and non-premium for Evernote. Yes. No, because I know that the transport is definitely encrypted if you're premium. That I'm pretty sure. But I don't know whether the storage is, but I believe there is a difference.
So premium user gets security.
Yes. It's actually one of the things they do. Yeah.
So this is from the WhatsApp SQLite file that is stored under document directory. You can see the messages, you can see the number of the contact person. You can also access to the address book of a user directly from these directories. For example, I can just for now open up iExplorer. This is my iPad. These are all the apps that I have. Let's say you know.
Jailbreak it, so
No, it's not jailbroken. It's not jailbroken. documents directory, you can see the library directory, whatever, everything is here. You can access all the files from here. Now, Apple has actually made it really simple to protect this data. They have a list of APIs to protect this data. For file manager, you use something called NS file protection key. For core data, there's something. For NS data, there's something. For database, also there's something. Last one is for keychain. So now question comes, how they actually secure it. Your file level data or the file level key is being secured by a class key, depending on what class you are using. And a class key is being secured by a master key. And a master key is being generated by your device key and your user passcode. So every device has a unique key, and the passcode is the passcode that you enter to unlock the phone. And once the master key is being generated, the user passcode and the master key gets deleted from. So basically, once you create the class key, the master key and the user passcode gets deleted from the memory for that particular application. So even if you are in a jailbroken mode, you cannot really access the memory address and find these keys. So it all depends on marketing. And there are certain period of time when this thing works and when they don't work. For example, when can you access these files? So there is something called NS file protection complete that only works when the device is unlocked. So that means if the device is locked, you cannot access these files. The second thing is, for example, if you are doing some background process, you're doing some location-based application, you're storing this latitude and longitude in the background, and the device gets locked. In that case, you can use something called NS file protection complete unless open. So that means if the file is open at the time of accessing, then only you can access it. And once you perform your or finish your operation, you can close the file. You can close the file descriptor, and then you can update to NS file protection complete. That means only when the device is unlocked, then it will work. But that again comes back to the stage, your device is as secure as your passcode. So if you are giving a 4-digit passcode, which is very easy to crack, then you're basically screwed. So now, that's why from iOS 5 onwards, they have this combination of numbers and alphabets that you can use in your passcode, that you can set. So then it becomes more difficult to crack the device. The last part is kind of interesting because this only works when user authenticates for the first time. That means for jailbroken device, you need to do a reboot, right? To bypass certain security. Once you jailbroke, then you need to reboot, right? So in that case, it won't work because you first need to authenticate it one time. So only after it's authenticated by user for that particular instant, it will only work. But still, the authentication needs to happen by this particular encryption key or the class key that needs to be generated by your device passcode or the device key. So if you bypass the passcode and whatever, the passcode is basically in there, and then you cannot access these files. I'll show you by putting this in my application. So this is your connection details loading. This is a delegate method where I'm storing it in my document directory. So this is where I need to put NS file completion, that particular option I need to pass here.
In the security community, there is a saying: if you have physical access, you're owned. Sure.
Server is protected. It uses this file to run encryption as one. They're not using one single API, one single parameter.
That's in the security community. That's the thing. You have physical access to your device, you're owned. I mean, you know, your MacBook, right? The FireWire port and now the Thunderbolt port has direct access to your RAM. I can dump out your entire RAM just by connecting your device to your Thunderbolt port. Entire RAM. Any encryption key that's on your RAM, it's mine. So if I have access to your device, I own it. That's all. The best security is lock and key, man. Lock your bag.
Okay. Apple provided it. They're not using it. WhatsApp security link. WhatsApp security link.
They have some
They don't have
permission.
encrypted. If you use a lock, app automatically encrypts. You just need to say that, hey, this is a safe file in this machine. So you should use that key. Say, if this file is not open, encrypt it. App it is not open. Using my thing.
But I guess it's probably slow when you return to it. So if it's a scratch file that you need all the time.
It's not a scratch file, it's a chat file. It can be found in the text.
Yeah, but when you have to reload your chat, right? Because the newer phones, I can imagine it's not so slow because of the encryption engine.
So now if I store this data in my document directory, it's going to be protected by this particular key. That means I can only access it if the device is unlocked. If it's locked, I cannot access it. So let me just delete my application from my iPad. I cannot show this on simulator. This is the file that I am storing in the document directory, right? I can do save to here, and I can save it in a particular location. But if I lock my phone, lock my iPad, and I click on save to, and if you can see here, this could not be copied because you don't have permission to that. I thought something was wrong. So basically, the only thing I did here is in the options that I passed is NS file permission. File protection complete. You can do the same thing for other operations like for port data you can do that, for database files also you can do that. So that if your device is locked, you cannot access these files. Now this thing is so obvious that rather than using it in each and every place, you can create an entertainment file for that. You can just add this thing to your application and it will automatically complete everything for NS file protection complete. Now if you want to change any of these other, for example, if you want to do background operation, for that particular methods, you can just use the other options that I talked about. You need to also enable it on your, for entertainment, you need to enable it on your development portal, and you need to download a different provisioning profile, and then only the entertainment will work. For keychain, you have the similar thing, but the only advantage of using keychain is it restricts to the particular device. So even if you have access to somebody's iCloud account and you downloaded some files which have been protected by these classes, and to your iCloud account, for example, on iTunes, then you cannot access to these files because it's protected by that particular device. Now again, the way keychain works is you needs the device key and the user passcode to encrypt the data. Earlier it used to be part of your library directory, but I don't think it's anymore. It's a database that all files can all applications can share, and that's why if you have the same bundle identifier, you can do single sign-on between applications. So, like for example, Facebook application, Facebook Messenger works on the single sign-on mode. So, in both the cases, you don't need to log in again. Some of the tips at the end is you need to do jailbreak detection in your application. That needs to happen in application did finish launch options. So that's the first method that gets called. If your device is being compromised, if it's jailbroken and you don't want your device to be used by jailbroken users, you need to wipe out any of the sensitive information that you're storing. That's the first thing you can do. Now, where it is useful, probably for banking applications, they wouldn't like jailbroken users to probably use their applications. For Facebook application, it might not be really useful. For a normal map application, it might not be useful. But again, you need to see what kind of application you're building and what kind of data you're dealing with. Another thing is that some hackers might do a hit and try kind of method. So it's like they're trying some password, they're hashing, they're reverse engineering some methods, and they're hitting your server. Let's say there's any protected API that you're trying to hit, and three failure errors, that is, it was locked down the API access to a particular user. So that's something you can do. That's how passcode or PIN, they block the access to that particular API. Books, these are the 3 books. The first one is definitely good. But these videos would give you a lot of ideas. The last one is protecting user data, is what I kind of refer for this talk. Again, they will give you very high level explanation. You need to go through the documentation, go through the white papers to understand. But this is being there on iOS 4 onwards. NS file protection complete is there on iOS 4 onwards. The other few advanced methods that I talked about is there from iOS 5 onwards. But developers don't really use it because they probably just go ahead with HTTP, the normal way of doing things. And that's why you see these popular applications like WhatsApp and other applications that store the messages in clear text format or simple SQLite database in their application document directory. I'll probably talk about reverse engineering, how to protect your data on jailbroken device in another meetup or some point of time in November or December. I need to explore a little bit more on iOS 6, try it with iOS 6, otherwise there's no point doing it for iOS 5 because everybody's moving on iOS 6. So yeah, that's it from my side. Thank you.
Can I ask one question? Sorry, again with the hashing algorithm earlier, actually doing client-side hashing, how would the password be stored on the server, and how would the server actually validate the login?
So basically, you need to request for this particular salt or the encryption key, right? And that request needs to be part of another API, let's say. You need to request for this encryption key or salt, and using this salt, you probably need to authenticate all other APIs or all other. But that again is useful when it is HTTP.
That's part. So the part I'm asking about is, so in the server you have the user's credentials stored in the database, right? Now the client is going to present, the server is going to challenge the client, listen, authenticate yourself. And the client is going to pass authentication details to the server. What is the client passing to the server to authenticate? So
the client can pass a certificate, the client can pass normal username and password. So it again depends on what.
I'm specifically referring to the situation of the hashing. The client-side hashing.
Yeah.
Because I think that it won't work at all. And I think it's not a good idea at all, unless I've missed something. And the reason for that is because the reason why we do server-side hashing or generating the hash on the server side rather, is so that the client presents the password, the server hashes it, and the server never knows the client's password. And the server will, or rather the server is never going to store the client's password or client's credentials in the clear. With client-side hashing, the server will end up storing the hash in the database the client has provided them. And
then again, you need to recognize this particular client, right? So there needs to be some kind of handshaking happening before you even share these details with the client.
No, but there is still going to be the question of presenting the credential to the server. The server still needs to figure out, authenticate you as it were.
Yeah.
And that authentication will, in client-side hashing, that authentication will inevitably end up being just matching the hashes, which means that you're actually just storing the hash as the password in the database.
No, so basically you share the same salt between client and server. You don't share the hash itself. So it's basically the password can be...
The problem is this, right? Whether you hash it on the client side or not,
Yeah.
what you're sending is what is being compared to. You shouldn't be comparing what you're getting.
Oh,
you
yeah,
should be
yeah.
you should be hashing what you're getting and then comparing it from the server's perspective.
No. On server side also you need to...
So what he's saying is right. What he's saying is right. The normal way to do it is you send your clear text password on an HTTPS connection, right?
Yeah.
So then you do it the same in a smart client or a web browser. You basically just send clear text passwords, but through an HTTPS connection. So when it goes over, then the server hashes it and then compares it with the hash.
In that case, you can use some encryption algorithm where you can decrypt and match.
No, HTTPS. HTTPS is good enough.
HTTPS and send the password.
Okay, encryption should be used for your data, not for password. Always send passwords as HTTP basic auth over a trusted HTTPS connection.
This
By
plain-
trusted, I mean the server should send a certificate that has a trust attached to it. Certificate works like this. A certificate is, it's a kind of, you can assume that it's like a business card. Okay, I say that I am Mukund, and here is my business card. When the client receives the certificate, it checks for the trust. I can't come to you and say, hey, I'm the president of United States. Take it, right? So there's someone called security trust agencies that send that trusts and signs the certificate. So you check that, hey, this certificate comes from VeriSign, so it is trusted. Your browser automatically turns your website's address bar or whatever to green, right? Sometimes when your certificate is invalid or something, it changes to red or yellow or whatever, right? Sometimes it's like there's a domain name mismatch. Google.com tries to send you a certificate that matches gmail.com. Are you sure you want to continue? I know that Gmail is from Google, so I'll continue it, right? So sometimes companies try to use the same certificate for all their domains, and if you know, you can kind of proceed with the trust. So first, ensure that you are exchanging data on a HTTPS connection, and second, ensure that the HTTPS connection is trusted. That's all. That's all you need to do about exchanging passwords or hashes or whatever. Encryption is for data, storing data from storing a data on your client.
But
You want to upload that data to the server.
there is
encrypt the password just before saving in the database.
exactly.
And when
Right.
the password is authenticated, the clear text password comes. It's again converted into some hash.
Yep.
And then
Right,
what
right.
is it? Database? This
When you
hash
store,
is-
you have to encrypt it.
Right.
Is that the correct word?
Yep.
Right.
Yeah.
Yeah, but we don't do it on network.
Yes.
you're saying.
It's a very crude hack to encrypt your password, hash your password, or do whatever you want, and then send it over HTTP. Because your hashing algorithm is not going to be as secure as
It
HTTPS.
doesn't work at all.
Yes,
No,
it doesn't work at all. There's always
No, because
doesn't work at all, right?
if somebody can sniff your hash and just
Right.
replay the hash, right? So
It's as simple as that.
Yeah.
Basically, expense in the password is clear to HTTPS.
Oh, HTTPS, exactly.
So you copy and remember that.
Right.
And then on the server side, in memory, hash, compare it to the database,
Yep.
clear the memory.
That's all. Yeah.
Yep.
Encryption is for data, not for your
client-side encryption.
yes, server-side encryption is also like that.
For passwords, you have to encrypt them before you store them.
Yes, you encrypt it using a salt, user-specific salt, encrypt it and put in. User-specific salt will prevent rainbow table attacks like the one we showed you.